So we will welcome Professor Wei Xiong Lim. He's from Singapore. Right now, he's the director of Institute of Geriatrics and Active Aging at Tan Tock Seng Hospital, Singapore. And he's also the associate professor of Lee Kong Chiang School of Medicine, Nanchang Technological University. And then today the talk is Osteosarcopenic Obesity Insight from the Jerry LABS2 study. Let's welcome Professor Lim. Thank you.
Yeah, thank you very much for the kind introduction. Thank you also very much to NHRI for this very prestigious invitation. It's always a delight to come to Taipei. And today I'll be sharing insights about osteosarcopenic obesity, or OSO, using insights from the GeriLabs2 study. Shown here are my co-authors, and I have no financial disclosures to declare. So in my talk, I'll first give an overview of OSO. Then I'll share some results from the GeriLabs2 study, and I'll close off with some reflections. Alterations in the bone-muscle fat interface is one of the changes that we see with age. And what this does is that it can lead to the characterization of the triad of osteoporosis, osteopenia, sarcopenia, and increased adiposity. So these conditions can kind of combine to give rise to different combinations of tissue derangements. So if we have overlap syndromes such as sarcopenic obesity, there will be fat and bone. Osteosarcopenia would be bone and muscle. And this theoretical entity of osteopenic obesity, which is the bone and fat. And OSO occurs when all three combine to give that triad. And it is believed in the conceptual model that this is the so-called most advanced stage in the bone-muscle fat interface, arising either from age or individual comorbidities. So why is OSO significant? I think in terms of pathophysiology, it has its origins in the mesenchymal stem cells. In younger age, the MSCs show a preference for differentiation into either the myocytes or osteoblasts. But with age, and especially in the presence of inflammation, the MSCs increasingly differentiate into adipocytes. And the ectopic deposition would give rise to, for example, the increase in waist circumference, deposition to visceral tissues, and of interest today would be the deposition into the muscle and bone. This dysregulation of the fat-muscle-bone crosstalk is occurring in a pro-inflammatory milieu and in a background of increased insulin resistance, which is driven really by the release of adipokines, myokines, and osteokines to give rise to the triple whammy of decreased muscle mass, decreased bone density, and increased adiposity, which over time result in the OSO syndrome. So the interest in OSO arises because there is this thinking that the combination of these three may actually result in worse outcomes than individual conditions. So in this study, OSO actually has worse in terms of weaker hand grip strength and lower gait speed compared with the non-OSO obesity phenotypes. And in the FreddieMax study, OSO is associated with a 2 to 5 times increased odds of frailty compared with non-OSO. When we look at the studies, there's quite a wide prevalence, ranging from about 6% to 25%. Reasons that have been cited for this variation include the fact that different operation definitions has been used, especially for obesity and sarcopenia domains. The characteristics of the study population in terms of the social demographics, the frailty status, and the study setting. So studies which recruit older subjects and with females tend to have higher prevalence of OSO, and social cultural factors may also be at play. So this is data from the Yishun study in Singapore, and I would like to draw your attention to the dotted lines for OSO and ignore the bold line for OS. So there are three trends worth highlighting. The first is that the prevalence of OSO increases with age. And this age-associated increase in prevalence is dependent also on the definitions used. So if we were to use percent body fat, this would result in a higher prevalence compared with the use of the fat mass index, and you can see that across the two panels. When we look at the sarcopenia definitions which use the appendix lean mass-based definitions would result in higher prevalence compared with those using the APGS 19-based definitions. However, there are gaps in terms of our current understanding of OSO. Firstly, there's a lack of consensus in its measurement and definition. So for example, for obesity, this can be measured either using DEXA, BIA, and anthropometric measures such as body mass index or waist circumference. And in sarcopenia, different definitions along with their different cutoffs have also been used as well. So at this juncture, the few generally thinks that there's little evidence to really support the additive or multiplicative health impact of OSO. And there are three reasons cited for this. Most importantly, I think there's a paucity of direct comparison studies with overlap syndromes such as sarcopenic obesity, osteosarcopenia. Secondly, most of studies are cross-sectional, lacking longitudinal data. And thirdly, there's also a lack of clinical pathological correlation with blood and body composition biomarkers. So in this critical review by Yugenbo et al., they actually put forth the case that it's not surprising that these three conditions overlap because they increase with age and they share common risk factors. Although there is evidence for the partial overlap, a causal relationship is yet to be established. And importantly, as mentioned, because of the lack of direct comparative studies, it remains to be proven whether the concurrent existence of sarcopenia, osteoporosis, and obesity really leads to an increased risk of adverse outcomes above and beyond the risk associated with the sum of the component parts. And they therefore conclude that it's insufficient evidence at this juncture to support the discrete clinical entity of osteosarcopenic obesity. So against this backdrop, in 2017, the Jaya Labs 2 longitudinal cohort study, which is actually part 2 of the first study, was kind of formed with the goal of developing a clinical biomarker phenotype of sarcopenia and OSO to predict the risk of frailty or function decline amongst completely dwelling older adults. So we assembled a team of multidisciplinary experts, and our goal was to kind of develop a deep phenotyping of OSO through serial measurements of clinical, blood, and body composition biomarkers. And our criteria was basically those aged 50 and above, completely dwelling, functionally independent, and cognitively intact. And in wave 1, the baseline, between end 2017 and 2019, we recruited 230 subjects. The goal was to have annual follow-up, but due to COVID, wave 1 data was incomplete and the study was stopped for 6 months. So for this presentation, I will essentially be presenting wave 2 data, the 2-year outcomes between 2021 and 2022. And we have about 193 or 84% of subjects who completed full assessment, including physical performance assessment. So this to give you an idea of the cohort. Mean age of 67, predominantly females and Chinese ethnicity, and consistent of very well cohort. The median SPB score is actually a max score of 12, and none were frail when we use the Morley frail criteria of 3 or more. So essentially, this cohort is not representative of the typical national cohort, but it's a cohort of fairly healthy older persons. And what we hope to do, therefore, is that we really want to compare between OSO and overlap syndromes. And our research question would be amongst healthy, completely dwelling or Asian older adults, what is the relative prevalence? What is the association with blood biomarkers and body composition parameters? And lastly, what is the predictive value for 2-year outcomes? So let's review AIM-1. We use a DEXA-based definition. So appendix lean mass for sarcopenia, fat mass percentage for adiposity, and bone mineral density for osteopenia, osteoporosis. And we use the validated Asian cutoffs as shown. So depending on the number of components, 0 to 1 would form our reference group. Overlap syndromes will have 2 components, and OSO is when all 3 components are present. Reviewing the prevalence, using the osteopenia definition, this is about 35.2%, which has a slight male predominance. When we use the osteoporosis definition, the prevalence kind of dips by about threefold to 12.2%, again with a slight male predominance. When we look across the age band, this jumps in the 50 to 60 age group from about 6% to about 13%, and this remains constant throughout the age bands. So we can see that OSO is prevalent even in a very healthy cohort of completely developing older adults. The definition matters. If you use osteopenia, it can be higher by about threefold. Interestingly, we have a slight male predominance. So this kind of differs from earlier studies, which were mainly done in post-menopausal women. But the male predominance was also reported in the Tianjin study. So I think more studies are needed in order to understand really if there is a gender difference. Next, let's review the relative prevalence. And this Venn diagram basically shows distribution of cases through the overlap of the three conditions. So when we have an osteopenia definition, what you find is that the osteopenia circle has most of the cases, right? So the highest prevalence will be OSO, followed by osteosarcopenia, and also osteopenic obesity. However, when we use the osteoporosis definition, the number of cases in the osteoporosis circle drops, and the cases are redistributed to obesity, sarcopenia, and sarcopenic obesity. In our study, we'll be using the osteoporosis definition. So for overlap syndromes, majority cases, about 3/4 are constituted by sarcopenic obesity, followed by about a quarter with osteosarcopenia. And this is important to keep in mind later when we interpret the data. Okay, with that, let's move on to aim 2, the comparison between OSO and overlap syndromes. So as mentioned, we have 3 groups referenced with 0 to 1 components, overlap syndromes with 2 components, also with 3 components. Analysis is at 2 levels. First, the comparison of OSO and overlap syndromes against reference group, and then number 2, that direct comparison between OSO with overlap syndromes. We perform one-way ANOVA with post-hoc comparison for the cross-section analysis of body composition and blood biomarkers, and for 2 outcomes, we perform logistic regression adjusted for covariates and baseline values. We have 3 groups of outcomes: body composition, looking at bone mineral density, appendicular lean mass, as well as fat mass percent visceral adipose tissue. For blood biomarkers, we kind of group them into 3 conceptual groups: insulin resistance with leptin, adenopectin, and HOMA-IR. Inflammation, we have CRP, MCP1, and TNF-R1. And metabolism, IGF-1, myostatin, as well as vitamin D. For 2 outcomes, we have muscle function, looking at strength and physical performance, activity level, looking at social activity, the French, physical activity, the IPAC-E, and life space mobility. And lastly, we look at health-related quality of life. So this is a comparison of the 3 groups. And what we can see is that for the OSO group, they are older, slightly higher education levels. Interestingly, in terms of anthropometry, they have lower body mass index, lower weight, and lower calf circumference. They are intermediate for hand grip strength and weakest for knee strength. No difference in terms of geriatric syndromes. Okay, so let's first review body composition. And what we can see is that for the OSO group, they have the lowest BMD, and this is significant for the comparison with both the reference group and also the overlap syndromes. When we look at the appendicular lean mass, what we can see is that the OSO group have the lowest as well in terms of appendicular lean mass, but this is only different compared with the reference group. There's no difference when compared with the overlap syndromes. And lastly, when you look at the adiposity, the OS group again has the highest visceral adipose tissue when adjusted by BMI and fat mass percent. This comparison is significant only when compared against reference group, but not against the overlap syndromes. Moving on to blood biomarkers, when we look at the group of insulin resistance markers, we can see that OSO group has the highest insulin resistance, as evidenced by higher HOMA-IR, higher insulin levels, and lower adenopectin levels, which is significant compared against both reference and overlap syndromes. For inflammation, somewhat surprisingly, OSO has the lowest level for MCP1 and also TNF-R1. And this is significantly different for MCP1 when compared against the reference group and overlap syndromes. Looking on to the metabolic markers, no difference for VITE. For myostatin, OSO has the highest level of myostatin. This is significant when compared against both overlap syndromes and reference group. And for IGF-1, somewhat surprisingly, it had the highest levels. Typically, in sarcopenia, we would like to see lower IGF-1 levels suggestive of decreased anabolic effect. But here it's actually the highest, and this is significant when compared against both the reference group and also overlap syndromes. Okay, so a summary of that whirlpool of results. Against reference group, OSO is lower bone mineral density, lower lean mass, higher fat mass percent and visceral adipose tissue, higher insulin resistance, higher myostatin, but a bit surprisingly lower inflammation and higher IGF-1 levels. And for overlap syndromes, similar findings except for body composition-wise, there's no difference in the direct comparison for lean mass and fat mass percent. Next, let's move on to AIM-3, which are the 2-year outcomes. We'll first review the muscle function. There's no difference in terms of predicting SPPB less than 10 at 2 years. But the interesting part is actually in terms of strength. So for hand grip strength, what we find is that the OSO group predicts a 4-fold increased odds of weaker hand grip strength at 2 years compared to the reference group. But this was not so for overlap syndrome, so that is a significant difference. When we look at knee extension, we see a suggestion of a dose-response relationship. So for overlap syndromes compared with reference, this is about 4.5-fold, and for the OSO, this is about 7.3-fold of in terms odds of weaker knee extension at 2 years. When we look at clinical outcomes, there was no difference in terms of ability to predict clinical outcomes at 2 years. So no difference for health-related quality of life, lifestyle mobility, physical activity, as well as social activity. So again, a quick summary for both reference and overlap syndromes. Mainly the prediction is for weaker strength at 2 years, but not for physical performance, activity, and health-related quality of life. Okay, so let's try to put things together. I think in terms of prevalence, OSO does show an age-associated increase in prevalence even in healthy, generally non-frail older persons. I think our study provides proof of concept of some differences between OSO and overlap syndromes. For the composition, this is mainly for the decrease in the bone mineral density. Adiposity may be visceral adipose tissue, but not for LMI nor fat mass percent. Blood biomarkers, there is increased insulin resistance in OSO and increased catabolism. There's also increased 2-year risk of weaker muscle strength, relationship more clear-cut for hand grip strength and the dose-response relationship for knee extension strength. However, there's no difference in activity levels and QOL and the so-called surprising findings of the blood biomarkers. We expected high inflammation and decreased anabolism, but what we found instead was that there were lower MCP1 levels and higher IGF-1 levels. So how do we reconcile that latter finding? It does appear that one possible explanation is that perhaps at the OSO stage, it is driven less by inflammation, but more by insulin resistance. And for insulin resistance, actually, there are 2 levels. And what is really driving the mechanism in OSO is the peripheral insulin resistance. So in peripheral insulin resistance, the IGF binding protein 1 levels actually drop. And because of that, there's an increase in the free or bioavailable IGF-1. And that may account for what we see. Contributing factors towards decreased IGBP-1 levels will also be decreased inflammation, intermediate BMI because of the inverted U-shaped relationship, and very interestingly, decreased leptin. And these are what we actually see in our results. So that again may drive the IGF-1. So putting together the increased IGF-1 that we see is not so much a case of increased anabolism, but rather it may be actually a marker of increased peripheral insulin resistance. So let's go back again in light of the findings to the propositions put forth by Bo et al. I think we do support that finding that OSO is quite prevalent, even in healthy older persons. We do provide more evidence of this clinical pathological association, mainly for bone, to some extent fat, and then from the blood biomarkers point of view, mechanistically, there seems to be increased insulin resistance and increased catabolism. However, in terms of outcomes, we're only able to show that it predicts weaker strength at 2 years. So this is more on the tenuous side. So if you put things together, we feel that at this juncture, there's still insufficient evidence to really support a discrete clinical entity of OSO above and beyond overlap syndromes at this time. But we have learned some things as a result of our study. So summarizing again, one, that OSO subjects may be older, with lower BMI, lower weight and calf circumference. Insulin resistance appears to be raised as evidenced by increased HOMA-IR, decreased aminopectin, and possibly here we postulate increased IGF-1 as well, and increased catabolism as a result of myostatin. So this would then lead to increased visceral adipose tissue, possibly also, although we didn't do it in this analysis, the infiltration of muscles as well, along with a decrease in appendicular lean mass index. Studies showing that insulin resistance and increased myostatin may be a risk factor for decreased bone mineral density and osteoporosis. So in the short to medium term, in our case 2 years, that could then predict weaker hand grip strength, and perhaps a longer follow-up may then lead on to frailty and other clinical outcomes. So we would be hoping to analyze our wave 4 data, and with that we hope to see whether we're able to see more differences in the clinical outcomes. So I'd like to acknowledge the team, both the investigators and also our research support team. Also like to acknowledge our funder, Lee Foundation, our committee partners, and last but not least, all participants for making this study possible. Thank you very much.
Thanks, Professor Lim.